for globally deployed systems, then we should be able to like help them figure out what's causing, what are the emergent or issues that are being observed by call stats on those systems. So a little bit about call stats before I dive deeper into it. We started in 2014. In the summer of 2013, we wrote our first line of code. We established the company in 14, raised a few rounds of funding. We do about 1 billion minutes each month. We integrate into various platforms, so Twilio, TalkBox, Amazon Connect. If you have a platform and we're not integrated into it, then talk to us. We'll figure that out. But over the last few years, what we've seen is that people want to use call stats, especially when you deploy the service globally, and it's not that the whole system's broken, but some parts of the system broken. It's not very clear what those things would be. It's not like a specific geography. It's not but you have a sense that there is something that's happening. And that may be attributed to a couple of things, like firstly, networks. If you're deployed globally, you have networks everywhere. And networks aren't, their performance varies over time, not only day to day, but hour to hour, minute to minute. So some of the degradation can be attributed to just networks being networks. The other thing is issues with local endpoints. So you could have a flaky Wi-Fi, which always causes some networking issues like packet loss, like burst packet loss. And we've seen that happen quite often. Like there could be a specific vendor or specific version of a vendor of a Wi-Fi station which causes this problem. And then to debug these issues can take like a lot of time before you actually understand it's the Wi-Fi. But one of the things that we wanted to do with this was what we realized over time is that people would come and query the system. There's a dashboard. They would run a lot of queries on it, like slice and dice the data. And they would only do that when there was a particular issue. Like that may be because they are looking at a certain metric, like let's say round trip time, right? So if you're globally deployed, you want to make sure your round trip time for most users is low. And one way to look at that would be to like run reports on a weekly basis, where you would go and say like, what is the average RTT for each of my end users in each of my geographies? And you run this cadence of reports, and if anything changes, then you go back and look at what may have changed. That's one way. The second thing is that people get feedback from their end users, and they would come to call stats and run some reports because someone in some geography or using a certain device is complaining, and then they want to see if it correlates with other people in the same geography or if it correlates with other people using the same device. So one of the things that we came to realize is that people were very reactionary. Like people would come and use the dashboard only when something happened, external impulse. And we started to think about how could we bring people back to monitor their service more often. Like that was one of the things that we wanted to create this feedback loop where people go look at this data routinely instead of like reactionary. And the second thing that we realized that was happening from our customers are talking to us and saying like, hey, you have all our data. Why don't you tell us what's happening with our, like what's interesting in our data that we should be looking at? So we kind of combined these two ideas and thought about a way to look at the data and then using a notification or using an email, send out a notification to our customer saying like, here's a list of things that we've noticed that are emergent issues on your system, and please go have a look. So the reason all this came about was like we got this input and we had a lot of data already in place. So we said, okay, now this is a problem that we could use machine learning to solve because that's what most people tell. And what we did not want to do was build an expert system because we had a lot of expertise in-house. And one of the things that we'd already noticed is that there were a lot of gotchas. Like we would run an analysis and we say like, let's look, the RTT is bad because, and we would postulate it, and then we go look at it, look at the data, and find that actually there were so many edge cases. Like we would say like RTT is high because like the routing is wrong, or like this is wrong, or that is wrong, and then we would go and look at the data, and it was not always very clear like if that was the reason. There would be multiple reasons, and once we looked at the data, we would be able to attribute how big the problem was and what was the issue once we looked at it. So it was not easy to build an expert system. So one of the things that we did was just build machine learning around it. And just to give you a sense of how big the problem would be if you decide to do it, is that typically you have a get stats API, which you can instrument at the endpoint, and you can just go and run get stats, and you can routinely call get stats, and you would get data. And typically, a single get stats would give you something like that amount of data, and that's just single query, right? And the thing that comes into is this data is basically typically divided into three parts. One is the transport, the other is endpoint, and the third thing is infrastructure, right? So you have the bottom left, which is what the get stats mainly focuses on, is like giving you all the raw data. So it'll give you like what is the audio packetization, what is the video frame rate, what is the frame size, and you get this as a snapshot. So if you query it every 5 seconds, every 10 seconds, every 100 seconds, you're gonna get like area under the curve, like what happened since the beginning. So how many frames were sent, how many frame sizes were sent. But it'll also give you like a snapshot of what's happening right now. So it'll give you an audio level. It'll give you right now what is the packet loss, what is the jitter, right? So this is really good because you can then query it routinely, capture all this information, summarize it at the end of the call. But apart from that, you can also like query the system to figure out, where the end user is. You can like use GeoIP, or you can ask explicitly geolocation. You can then correlate that with an ISP name or AS name by doing a reverse geo lookup based on the IP address or on the location. And then there are a bunch of things that you can fingerprint, which is like, okay, what device are you on? What's the operating system? What CPU type? So that you can basically get a sense of if the load is on the, if the media pipeline is generating the load, or is there something else that's generating the load on the device. And lastly, you have infrastructure, which would be like, if you're using a turn server only, then you have the turn server addresses. But then you can, if you're using an SFU, then you could have server locations in the server network, and then so on and so forth. So you can basically build on top of the get stats a rich rich metrics just by pulling more data from within the system or from adjacent systems. And what happens at the end of the day is you take all this data and you have many metrics. As I said, like you have all these things. You can create measures out of it, which could be averages, means, percentiles, skews, kurtosis, depending on like what you want to do. So at the end of the call, you can just basically say, I want to do all the statistical analysis on each of these metrics and do per metric several measures, right? So for example, percentiles, you can go 10 percentile, 25, 50, 75, 95, 100, and then you know what is the kind of spectrum of delay, for example, on this call. And depending on how many samples you have, like if you sample every 1 second, or if you sample every 10 seconds, then that creates the richness of data that you could have. And in our case, the advantage we have is like we have several customers, so we can aggregate that across M customers. So in the end, we have lots of data. And as I said before, the reason why we went down the path of machine learning, I'll come back to a little bit later, is that a lot of times when we ran these hypotheses, you can see this from the fact that we publish a WebRTC metrics report on a yearly or quarterly basis. There are about 7 or 8 of them in the last few years. And a lot of the results, when we published them, we were always surprised. Like we would see like a delay curve, and we would say like, oh, this is not as bad as we suspected, because we thought that things were worse. Sometimes we would see like things were really worse than what we thought they were. Like we said, oh, the jitters are highly varying. We did not expect this. So things like that. So we realized that whenever we had an intuition that we would say like things would happen this way, things did not result the same way. So we decided that we would not use our expert knowledge on any of it, and give the system a lot of data and see what it figures out. And then we can use the expert analysis as a second step. And that helped us because, one way to look at when you have a lot of data is, what are you trying to do? Like, are you trying to build, if you have a lot of data, then you have to like handle all this data and build a user experience, process it, understand how to process it. And on the other hand, what you want to provide is you take that complexity and build insights on top of it, right? And insights can be based on, if it's based on a lot of data, you have to figure out where the customer value is. Is it like in the data, or is it in the insights? And that's something that we've been playing with for the last year and a half. So a lot of the results that we'll talk to towards the end of the session is about our experience over the last year since we deployed the system. Um, so typically when we talk about troubleshooting, we notice there's a very simple pattern where people generate a hypothesis. This may be because like someone complained, like you look at end user feedback and you say like this is what I think is happening, or someone says like let's run a weekly, monthly report, and you have an hypothesis for that. Because that may be because you deployed infrastructure in a certain new location and say like this infrastructure we deployed in this location because it's going to reduce like jitter and latency, and then you want to go validate that after a while. And the second thing is once you have an hypothesis, you want to be able to generate, like you want to go and see if there are anomalies in it, and then you want to filter data, and then you want to run through that whole analysis until you find what you're looking for, or you find something else which can be the interesting bit. So in many cases, what happens is that you need experience. If you don't have a good hypothesis, you're not, and you have lots of data, you're not going to find anything, because you can't be like sitting in front of the data and say excite me. It's not like you need to go and wade through that data until you come upon an hypothesis. It may be built by yourself, or you hear someone else. And that comes to the second one. Not all anomalies are obvious. Like a lot of the times we saw the anomalies, we never thought those were the anomalies that we were looking for. Look at the data long enough, you start to see some patterns that you did not expect. And so basically the system that we wanted to build is not a system that goes and tells you what the solution to the problems is, but basically come up with problems that you would go and investigate, right? So basically, if you launch your service and it's been running for a while, what you would want is like a notification which comes up and says something like, hey, between the last month, what we've noticed is that quality for the users in, let's say, Asia or Japan is decreasing because the RTTs are increasing, right? And that is like a very good way. Then it doesn't say like why the RTTs are increasing. You have to go investigate that, but at least gives you a starting point to go and slice the data in a specific way, so that then you can go and find what correlates or causes it. And what we're looking for, like what we've been doing is like build more and more correlations into that statement, so that we could say like main reason is round trip time measured in Asia, but server locations are X, Y, and Z. And as we iterate on this product, we're going to add more and more correlations to that statement. And the idea would be then for the customers to go and slice the data to figure that out. So let's take a step back. So the idea was to find hidden call issues using machine learning. And one of the things that if you were to build a system, this is what you would need to do: is you would need to collect a lot of data, then make sure that the data makes sense, because there can be a lot of bad values, like there can be endpoints that report spurious values. Then you have to clean that data. Then make sure that you understand what you want to do with the data. Then run some machine learning classification or clustering techniques. And hopefully at the end of it, you have the clustering and the classification shows you some interesting thing that you could then go and look for in more detail. So one of the things that we looked for, like for example, when we started this analysis was feature reduction was the main place where we spent a lot of time. Because we did not want to use our own expertise, we basically said, go look for interesting stuff, come back, tell us what is interesting. Then we'll dimension the data in a way that we could go and run, like build models on top of that feature reduction based on elimination, selection, or extraction. Like if we find interesting things, then we'll do it. So one of the things that we've been running for the last year is, especially for a lot of CPaaS providers or people who have global infrastructure, is figuring out why, like everyone says latency matters. And we just had a talk from FreeSwitch where they were talking about millisecond latency. So latency is like the most important thing. So we said, let's focus on latency, because that's like the core value prop that everyone brings to the table. And typically round trip time would be measured end to end, or would be measured to the SFU or to the media gateway. So depending on if you're a peer-to-peer system, it will go end to end. if you use RTCP, or it calculates RTT just between the sender and the receiver, and if you have an SFU, it terminates the RTCP, so the RTT is only measured to the SFU. And then you could, like for example, in a call with 3 people, you could basically say my RTT to the SFU is X, someone's is Y, then you could add X plus Y and divide it by 2, that's your one-way delay, right? And that would be your end-to-end delay as well. So quickly jumping into an example, because we did all this, so there should be fruits for you to listen to. So one of the things that we did over the last 6 months, so the results are a bit dated, about 3-4 months old. We looked at the notification sent to one of our customers, which does about 1 million to 10 million calls a day. So we're talking about someone like a call center, but fairly significant call center with platform with a lot of data. And one of the things that the system, so this is an analysis after the fact. So the system came out and said, there are 3 things that are broken in the system, go investigate. And instead of showing you what the answers are, we're going to go the logical way if you were looking at the data, right? So the RTT distribution for the service was, for everything below 150 milliseconds, that was 68% of the data, right? So that's low RTT. So 70% of the users did not have any issues with RTT. And about 19 and 12% had issues with RTT between 150 and 700 milliseconds. And then there was about 1%, which was over 700 milliseconds. And as I said, the system already told us there were 3 issues. It was not these 3 issues, but basically it had identified about 20% of the calls, or 22% of the calls globally had issues, and they had 3 reasons for it. And we said, okay, and we knew RTT was the issue, so it shows up here. It shows 3 clusters, medium, large, and very large. These are just RTT labeled. And we just said, okay, let's correlate RTT with everything that we know, right? So if you're naive, you would just say, like, pick all the things, run a correlation, give me a table, it gives you that. And so there's media RTT for audio, there's video RTT, and there's local location and server locations. And one of the things that you can see very clearly is that there's correlation between audio RTT and video RTT. That makes sense because there may be people that use both media, there's some calls which are just only audio, some calls which are audio and video. In the cases where video was used, it was highly correlated. And since we've not sliced and diced this data, this is all the data for all the 100% of the calls, so not the 33%. The other thing that you can notice is that locations, especially the longitudes, correlate as well. And that kind of makes sense if you look at the map. And if you think of most people in Asia, Europe, and USA, we are mostly northern hemisphere people. And you would not expect RTTs to correlate with latitudes, because like at the same latitudes, you could have like 4 locations, which would give you a very large spread, like Paris, Moscow, and somewhere in northern or southern Canada would correlate on the same latitude. But on longitudes, you can see that the continents would separate very well. You can see a correlation that's better. Like you can see RTTs correlate with longitudes, which makes, like, at least validates the hypothesis that the continents are on different places. You see some correlation with longitudes. So we were like happy. We're like, yeah, okay. We kind of now understand some correlations, but we actually don't have any of the answers. Like, it doesn't say which continent, or is it, like, we do know location plays an important role. Beyond that, we don't know anything. So one of the things that we did was we took the data and we ran some clustering analysis. In this case, is Gaussian mixture models. And so GMM, we ran it. We looked at some analysis, and we found that if we made 6 or 7 clusters, that was the ideal point for large-scale systems. And what we found was that it broke into 6 clusters, and it kind of showed up like this. So you see 6 colors and clusters all over the place. And the good thing is that the 3 things that it reported on were these specific clusters: the blue, the brown, and the green. those are the clusters that we're going to go investigate because they were separated and they were marked as potentially the cause of the issue. So this is the machine learning system telling us that there's a problem with 32% of your calls, and we took 100% of your data, and it breaks down into 6 clusters. 3 of them are bad. Here are the 3 bad clusters. And basically, we plot the 6 values that we showed before, where we talked about, so you have the mean audio. You can see the distribution of the audio. You can see the distance. You can see the local latitude and longitude. You can see the jitter. You can see loss rates. You can see some of the network distribution. So in this case, it's saying 60% of the high RTTs are from this location. And it says like network conditions are good. And that is mainly because like if you look at all these values, they're all to the left, which means that like none of them are significantly contributing to the RTT. One of the things that does show up is that the distances are super high, and so shows that the local longitude and latitudes are somewhere in Asia. Like, and I think it's 50 degrees north and some 20, 30 degrees east. That's like Russia or someplace. So there's like Russia, like these calls are coming from Russia, and the RTTs are super high, and they're going off to far locations. And nothing here is suspicious for you to go and investigate. There's no congestion or anything that you should be worried about. It's just like, these are long distance calls. They are 16% of your data, 16% of the 32%, so you don't, maybe there's no action to take here, like apart from keep track of this, which is good because then you're not spending time investigating dead ends. The second cluster it showed, which is 20%, says like, okay, in this case, this cluster, users are all over the world, so it cannot like make any correlation with users, at least from the data that it has. It does see bad network conditions because it can see large jitter and fraction loss. And what it can also notice is, so what it hypothesizes is that in this case, the bad cluster is, or the high RTTs are because of congestion control, right? So like this is again an area that you can go and investigate which ISPs, which regions, like is there something that you can do about it? And the third cluster, which is 50% of the data, so like this is where 16% of like your bad calls are coming from, are, it says good network conditions, but local users are in Asia, and main cause of large RTTs can be large distance. And one of the things that we did not realize initially, over time what we realized with the system was that most of the servers were deployed in Europe and the US. So a lot of the large RTTs that we were seeing because of distance were not necessarily distance, but they were hairpinning. Like there could be 2 people which were close by, but the infrastructure was just so far, like 2 people in Philippines, but the servers are in LA or in San Francisco or wherever, and in the US. And if there's a person in Hong Kong talking to a person in Philippines, the call was going through through the West Coast. So to analyze, like basically what the system ended up doing was it sent out 3 notifications, which said, basically came down to two problem areas. You should put more servers in these locations. And one area which contributes to 20% of your data is congestion. And this, we don't know what we can do about it, but you can definitely go and look at and see if there is something you can do. But this really helps the customer, because if you think about 15, 16, 20, that's like about 80% of the data we had answers for. For about 15, 20% of the high RTTs, we don't have any correlation for as yet. And that saves a lot of time, because if you just get a notification which says these 3 things are the issue, you don't have to go and segregate, create hypotheses for your data when it's already creating hypotheses for you. So in the end, I think the real solution to this is something that you can keep track of using machine learning based on your data, create clusters, see how the clusters change over time. And basically, in our case, we are building notifications or APIs around it, which either the customer can query or be notified by email or through webhooks to go look at specific things that are broken in their system. And that's my last slide.
Microphone. Thank you. Any questions?
Hey, if you go back a slide, where you had kind of this, do you think we could ever get to the point where this was the notification that we get?
That's actually what I think the notifications, the left side, is not the two sides on the right.
Yeah.
Like that's what we're trying to get to. I think in our system, we would probably need a little bit more knowledge about like if we have the full view of the system or not, and that's something that we are always careful about. But if we think that we have full view, there's definitely, this is super easy to build as a next step to say like, we have X number of users in this geography, and there are no servers nearby, and you should think about it. And when I said we're not totally aware about the locations, I also mean that we don't know if people are on Amazon or like on Vulture or what, right? So like we don't know how close they can be. So that always is a very good thing, like very good question that we've been asking ourselves, like what more information do we need for the system to get closer to the right? And this is just the first year of us doing this. So we've just embarked on this journey. So thank you for that input. We'll definitely try to.
Sorry. We would happily let you ingest all of our server locations and everything if. Yeah.
That would be, if someone would do that, I would like appreciate it, and we would be really happy. And I think Leonard has been asking me like, how do we know? And like IP addresses don't help because Amazon moves the IP addresses so frequently. Like you mostly have like the wrong location for your server side, unless someone tells us authoritatively that it's in US East and it's in Virginia and it's in this cluster. That is the piece of information that's kind of missing. We're always guessing about that.
Excellent. Any other questions? No? Right. Well, big thank you to Varun from CoolStats. I'll come up here. We've got a